Hello everyone, welcome to my channel. Today I'll discuss about file structure in DBMS. So before I start, subscribe the channel and press the bell icon for more notification. Thank you. Hello everyone, today is about file structure in DBMS. So before we understand about file structure in DBMS, now the first question is what is file? See, a file is an object on computer, means where we store information or data or a command on the computer, okay? Means a file means where we store information or data. Now in DBMS, what is file structure? In DBMS, we study about file structure. See, DBMS is a collection. See, DBMS is a collection of files. DBMS is a collection of files. See, DBMS is a collection of files, and files consist of sequence of records. Files consist of sequence of records, and records consist of sequence of fields. Records consist of sequence of fields. See, first thing is DBMS is a collection of files, and files consist of sequence of records, and records consist of sequence of fields. Now see, if this is a database, if this is a database, and these are the, you can say, these are the records 1, 2, this is a database and these are the records 1, 2, 3, 4, 5, 6. Records means these are the files, and these are the, you can say, means these are the, you can say, fields or block. You can say these are the fields or block, okay? So these are the records or files, and these is after we see 1, 2, 3, 4, 5, 6. These are the all are the records, and these are the blocks, or you can say these are the fields, okay? Now, and the next point is file can be stored in different methods on secondary memory. Secondary memory is hard disk, means we can store the file in three ways, in three different ways on the secondary memory. The first is contiguous memory allocation. Contiguous memory allocation. Contiguous memory allocation. See, we have seen in operating system, what do you mean by contiguous memory allocation? See, contiguous means we have seen means we cannot break the process. Means we cannot break the process. We have to store the process in linear fashion. Means in a contiguous fashion means we cannot break the process. Okay. So similar thing applied here also. Means in file also we will not means we are storing file in contiguous memory allocation means we are not breaking the file. Means we are storing in contiguous fashion, or you can say like an array we are storing. Okay. We cannot break the file. Okay. Now the next type is this linked allocation. That is linked allocation. So you have understood only what do you mean by linked allocation. See, contiguous allocation means we cannot break the process or we cannot break the file here. In linked means is in a non-contiguous fashion. See, in operating system we have studied about non-contiguous fashion. So similar thing here means in non-contiguous fashion we are storing the file. So then what do you mean non-contiguous fashion? Non-contiguous fashion means, see, if this is a block, if this is a one, you can say secondary memory or hard disks, and these are the blocks 1, 2, 3, 4, 5. So these are the blocks. See, now 1 number block, 2 number block, 3 block, 4 number, 5 number, in number 8 like this, 8, 9, 10. Now you have stored a file on 2 number block. You have stored a file on 2 number block. Okay. The next file you stored on 9 number block. Okay. The next file you store on 5 number block. Now see, this is not in contiguous fashion. This is in non-contiguous fashion, means in a linked allocation, means we are storing the file with the help of pointers. See, now 2 will point towards 9 and 9 will point towards 5, means we are storing the file with the help of pointers. That is a non-contiguous fashion, means we are breaking the file into pieces. That is means non-contiguous fashion, or linked allocation means we are storing the file with the help of pointers. Okay. So the second point is linked allocation. Now the last one is index allocation. See, index allocation. See, in the upcoming videos we'll study about indexing. There are various indexing, and there are primary indexing, there is cluster indexing, there is secondary indexing, the multi-level indexing are there. Now in this video I'll give you a brief idea about index allocation. See, index allocation and why index allocation is done. This index allocation done, the measure or the important point is means to increase means searching will be fast. If you do indexing, in database, means searching will be very fast. Now how it is done, I will give a brief idea in this video. See, this is one, you can say this is one hard drive, secondary memory, and these are the records are there, 1 2 3 4 5 6 till 100 records are there. Okay, now see, this is one block B1, this is another block B2. Similarly here you can say there are 10 blocks, means there are 10 blocks. So in one block how many records will be there? 10 records. There are 100 records, and in one block there are 10 blocks. In one block how many records will be there? 10 records. Okay, so this is the 10 number block. Now see, in this whole database, in this whole is hard disks or secondary memory, all the information is there. Okay, now if we do indexing on this secondary memory, the table will look like this. See, the table will look like this. Indexing table will be short. Okay, indexing, the first point, indexing table will be short, and it will not carry whole information of this table. It will carry only the block information, means it will not carry all the records. It will carry only block B1, B2, B3 till B10. Okay, B1 to up to B10. Now see, it will carry only the block wise, means block wise information. It will not contain all the record information. So with the help of indexing, our searching will be fast because the size is less, the size of the table is less, so the complexity will be also less. So size of the table is also less, complexity will be also less, so searching will be very fast with the help of indexing. That's why we done indexing. So there are various levels of indexing: the primary indexing, secondary indexing, cluster indexing, multi-level indexing. So we will see in the upcoming videos. So means whole file is not sorted, so only important record is stored. Okay. Now in the upcoming videos we'll see about dense indexing and sparse indexing also, the difference in dense and sparse. Okay. Now our next point is, we are storing the file in two types. One is sorted and unsorted. Sorted and unsorted. Now is the difference between sorted and unsorted. Okay. See, there are two types of files. One is sorted file, sorted, and is unsorted file. Now it's the basic difference between sorted and unsorted file, and the time complexity required in sorted file needed in sorted, and the time complexity needed in unsorted file. Okay. Now see, the first difference is sorted and unsorted files can be sorted only according to one attribute, that is search key. That is, you can say search key, primary key. So we have studied in DBMS what is primary key. Through the help of primary key, we are finding the whole information of the student or the employer of the whole table. So this is search key, or you can write primary key also. Primary key. Okay, means the table is sorted according to only one attribute. Now for example, see, this is a table. One table is there. Here student ID, student name. These are the attributes. Then student branch. Then you can say is date of birth. Now see, there are 4 attributes are there in this table, and this table is sorted, and the search key means only one attribute, means only one attribute. You can take student ID, or you can take date of birth. So only with the help of one attribute we'll find the whole information of the table. We'll find the whole information of the table in a sorted way. Understanding? No, means with the help of only one attribute, the whole information will be sorted. Not with all attributes, only with the help of one attribute. And in unsorted, what will happen? In unsorted, say random order file and can be stored in any order or can be placed in order. Means the main important thing, there is no means primary key, there is no search key there. So it is an unsorted file. Then searching will be very fast. Then because it's sorted, so information searching will be very fast. So time complexity will be order of log base 2n, means binary search. Okay. Searching will be slow compared to sorted file. Then time means if there are n elements, we are searching for n element, for the last element, then searching will be linear search. So its time complexity, it is order of n. For the n element, we are searching for the last element, so order of n. Insertion deletion will be difficult. Why? See, if there are 100 stacks of if there's a stack and it contains 100 books, 1, 2, 3 till 100 books, 100 books. Now see, now if they say to delete the 50 number book from this stack, it will be very difficult because it will swap out from the upper book, so it will be very difficult if this file is sorted. And the file is not sorted, see, the file is not sorted here, and there are same stack is there 1 to 100. Now if they say delete any book from this stack, now it will be very easy, and if they insert any book in this stack, it will be very easy. Means it's not applicable. They are saying delete any book from the stack, so it will be easy. But in sorted, if they say delete the 50 number book, 15 number book, or 40 number book, it will be very difficult. This is why it will be easy. It will be difficult for sorted file deletion and insertion, and it will be easy for unsorted file. Okay, because in unsorted file, if they say delete any number of book from any order, so it will be very easy. Okay, so this is about sorted and unsorted file. Okay, in the next video is about indexing. Thanks for watching. Thank you.